We're back again. Okay, this is about the Acom 2000A I picked up and some things I noticed. And this short vid is pretty short, is going to be all about the importance of a properly tuned antenna in regards to reflected power. Something I observed with the 2000 Alpha after running like the PW1 and the AL80A with an outboard tuner. I never really noticed this stuff before. I never really cared. But I'm going to show you something. So let's get over here. We're going to boot the amp up. And we're on the G2. And this is Thetis. And we'll go ahead and get this thing lit up. And I want to talk as it's booting up. As it's booting up, what you're seeing, what I noticed on the screen. Okay, so I'm on an 80 meter loop. And the loop is matched with a quarter wave times 0.85 velocity factor of RG11. Now, it's a monoband 80 meter delta. And not originally, but I moved it, back in July into a multi-band delta. And I had to add a lot of wire to it because I had to drop the point of resonance down, way down below 3600 to get it resonant across multiple bands, going up 40 and up through 10 meters. Well, when I put the matching section back on it, I never took the wire off. And I'm going to show you what you're seeing right here is, if you notice down the lower, now remember this hump right here regarding what I just said, this is an increase in sensitivity in the antenna, increase in receive, which tells me that the antenna is high in resonance, right? So yesterday I went out and I took off about 6 feet of wire. I looked at where it was cut across the top section and I took it off. Well, it moved the hump here, where it's most sensitive on receive, from way down at the bottom all the way up here. And what I'm about to show you is a byproduct of that. So I need to add some wire and move this down. I know you're saying, why don't you just use a VNA? Well, I did use a VNA, and that's what I saw as well. But this translates to efficiency of energy transfer and the importance of having a well-tuned antenna for an area of the band that you operate primarily in. And it also relates to, which is basically reflected power, right? So I don't run a ton of power, as you guys know. I mean, I'll run 1,300 watts if I have to. And there's the amp, she just came online. All right, so what I'm going to show you now that I explain that, what you're seeing on the screen, I'm going to show you what happens. Okay, let's get over to okay. So let me point some things out to you first. So ignore this. This is the temperature of the amplifier. This is the output. The top bar goes across. That's the output. This is the reflected right here. How many watts are reflected? All right. Now, if the antenna is properly tuned, let me bring it out of standby. So we're in operate now. If the antenna is properly tuned, this amplifier should be able to tune that with 0 reflected power. And I'm going to demonstrate that. Now, a lot of people will say, well, what's the difference? Well, to me, I'm the most anal retentive person you've probably ever known. I don't like reflected power for 2 reasons. One, you're losing a certain level of transfer of energy. So let's say you're running let's say before I took off the 6 feet, right? Because it was way low in resonance, I was, when I jumped on 3854, holy crap, out of 300 or 400 watts of output, I had 100 watts reflected. That ain't good, right? So you're just wasting energy. That's a waste. So what I wanted to explain and show in real time and explain what you're seeing on the amplifier. Now remember, this meter right here is reflected. I want you to watch that. Now it's better, much better than it was, but it's high. I'm going to go out and fix it. So I'm going to place it probably down, somewhere, if I move it down into the 3750 range down in here, this whole hump should slide down, once I add a little bit more wire to it. I got a little carried away and cut too much off. Anyways, so what we're going to do, let me set the output, my drive level. I'm going to put it there at 10. And what we're going to do first is we're going to go up to, let's go up to 3900. So what I'm going to do is bump it. Actually, I'm going to do I don't think I've ever tuned it on 3900. So what we're going to do is we're going to initiate a tune cycle. And here we go. Okay, so if you watch that meter closely, it looks like I'm a little high. So it looks like I've got a little bit reflected. So when I key it up, we'll take a look at it and see what happens. So let's key it up. Hello, is this frequency in use? A1 GMM. Testing, and we have approximately 300 watts out. 300 watts. Is this frequency in use, please? Okay, so as you can see, yes, the antenna is tuned very high because there is 0 reflected power. There was nothing on this meter. So let's go all the way down here. We'll go down to, let me get to the other screen here. So you should be able to see it now with where I am on the band. Before I was up here. Now I'm all the way down at the bottom of the phone portion of the band. So let's go to, we'll go to the old tried and true, 3615. So it's already tuned down here. So I'm going to just bump it. And the amplifier, you'll see it switch to the bottom end of the band. There's already a tune memory in there. So, okay, see that meter pop up? Almost 50 watts reflected. So let's hit this and see what the reflected power is. Is this frequency in use? K1 GMM. Test. 1, 2. Testing. 1, 2. Audio. 1, 2. Check. Is this frequency in use? Just testing reflected power. K1 GMM. Okay. So as you could see, reflected power was, I'll get over to the other camera quick. So the reflected power was about 25 or so watts. So out of that 300 watts, I was losing 25 watts. So, and that's because the antenna is tuned too high. So I just wanted to demonstrate that, the benefit to having a properly tuned antenna. Now works the same with any antenna tuner. If you're force loading an antenna, there is going to be, even though it will show a flat SWR, there's going to be reflected power in there. Here's the other reason why I don't like anything reflected. I don't like anything coming back to me. Okay, nothing. I have a lot of sensitive equipment in here. This stuff over here, never designed to be in an RF rich environment. I don't have any RF on my audio, guys have told me, so they would say something if they heard it. But I had like 100 watts. Yeah, almost 100 watts reflected. That's a lot. Out of a 400 watt transmit, 100 watts is reflected. Are you serious? You're losing 25% of your energy, man. So I think that's about it. Oh, yeah, I wanted to cover one more thing, and this is in regards, so more specifically, the Acom 2000 Alpha. Yeah, it'll handle that, no problem. What I realized is that the Acom 2000 has a limited range where it will tune in. I believe it says in the documentation, don't hold me to this, I thought it said the antenna needs to be 3-to-1 or less. I thought it might be 2.5-to-1 or less. So that's not a very, that's a narrow window. From a 1-to-1 to 2.5-to-1, I mean, you can take a manual tuner or even probably like a Palstar HF Audio. That thing will snap a 5-to-1 in there like no problem. So it's kind of interesting because the PW1 handles the tuning better. The Acom does not have as broad of a range. So I just found that kind of interesting. Okay, so that's basically it in a nutshell. I'm waiting for it to stop pouring. It is pouring chickens and roosters out there, man. I'd say cats and dogs, but that's cliche. So I got to go out and add some wire, but I'm not doing it in the pouring rain because I won't be able to. I'll try and hit it with a torch and some solder, and the rain will hit the wires, and it'll cool them too fast, and the solder will just drop right off. So it ain't going to stick to it. So anyway, so we'll wait. Hopefully, I'm kind of watching to see if it dies off and get out there and straighten this crap out. All right, 7-3, you guys. Have a great day. And we'll be back, I'm sure, with more